tempered down. The other guy here, the h of x, is this 125 again, 5 to the third, times 5 to the negative 3x. What if I say that's 5 to the negative 3 raised to the x power? Multiply negative 3 times x is powers to powers. I'm multiplying exponents. H of x is 5 to the third, or 125, times 1 over 125 raised to the x power. So, no, I can't cancel these, because this 5 to the negative 3, this 1 over 5 to the third, this is being exponentiated, and independently outside of that exponentiation, you've got this 125 times that silly thing. So what I'm going to ask you to do for Monday, to try the rest of these, that'll be part of your homework. We've been at this for almost an hour, so why don't we take a break for about 5, then we'll come back and do what I'd like to do, which is going back to the original plan. And we'll take a look at practice with looking at the problems we didn't finish from Monday. So we'll be needing class examples for Monday, and then we'll do as much as we can for using logarithms to solve exponential equations for today's class examples. So the next thing we'll need is the class examples we used on Monday, and we stopped right here. I think you can see we were solving some equations last Monday, and we stopped right there. We did the change of base problems, and then we solved these equations. So let's break for about 5. We'll come back and we'll start working all those problems out and live happily ever after.
The nameless one, you're about to go up against SAD, Shark After Dark. I'm sorry, what level is this guy?
So I have 114. We'll begin again around 120.
My SP! This is going so bad. No! Boost! Dad, quick, throw the blue shell! Wait, I want to start over. I think you can stay racing on the same road, but you can't stay with a loss. It's so embarrassing. I got smoked by a K-pop. Shut up. What's wrong? They put him in the beginning to trick me. It's a false sense of security. Like, oh, who's this guy in the box car? Who's mom? Come get your mom. Your mom's driving on the Honda box. You are. Come get your grandma, bro. Doing absolutely smoky. My mom can smoke you. Smoke your mom, too. Your mom likes me too much, so she wouldn't want to do that. I have your mom's number in my phone. Alright, here we go, Suzuki round 2. It's him again. It's your grandma. Fun fact, whenever I'm in Tokyo, we take taxis, I usually get really horrifically car sick, so I feel like I've probably been on this road before, but my eyes were closed because I got so horrifically car sick, I didn't want to do it for the rest of the day. This is not a drifting game! No! Whatever. What's my... Oh god. Wait. It's him again! I can't catch him! I gotta look at my... Oh, okay, that's how you do it. Okay, I figured it out. No! Get this one. You're supposed to keep going! Yeah! I was trying to do a little spin! I still kinda did it! Nailed it!
Must quiet my mind.
SP gauge increases by 2%. Wow.
my first item yet. Maybe because I'm playing a baby carry, but
Is this? Are you trying to go me into downloading League again or something?
bro, like League is fun. Like, you just have to say no when when Lord asks you to play, bro. Like, when he asks me, I just tell him I'm busy. Even when I'm not. Enemy chaser. Like, the synopsis is on. Oh my god. John C. Shit, fuck with.
Thundercloud. Boom. Thundercloud.
Hey, we'll be starting in about a minute.
I thought this was a video.
Honestly, low-key me too. I'm like, oh damn.
Boom. Thundercloud. Thundercloud.
Well, I have 120, so here we go. You're looking at the class examples we didn't finish from Monday. Does anyone remember how 9, 10, and 11? Because they all involve calculations which are not obvious from your calculator unless you know a formula. Does anyone remember what that formula is? You're asked to find the logarithm of a number to a very strange base. So what do we have to do? Anybody home?
You take the natural log of it?
Well, careful, that's part of the story. You've got two options. If you have the logarithm of a number to a base that you don't like, oops, I'm going to do this on the document camera to make it a little bit easier to see. If you're taking the logarithm of a number to a base you don't know, you've got two choices. You can take the natural log of the number divided by the natural log of the base, or take the log to base 10 of the number and divide by log to base 10 of the base. So you'd take your calculator for the first one, and of course we did this before, so just one quick repetition. Log to base 3 of 78, I could say natural log of 78 divided by the natural log of 3, and that looks like I should get some number. How do I know I'm right? Well, we want the log to base 3 of 78. We think this number is the log. In other words, it's the exponent. So if I take 3 and raise it to that number, what should I get?
78.
Bingo, and we do. So we did those guys in class on Monday, and I hope we remember that. If not, we've got a lot of practice problems in My Open Math that deal with them. So I see something came up in chat, but would you please speak up so we can move on?
I was just asking, my Wi-Fi went out, so I got disconnected. I was just asking what happened in the past, 2 minutes.
Well, we went to the Monday class examples we didn't finish, and we're going to finish them off first before we do today's class examples.
Okay, thank you.
Okay, so we did, I think, 9, 10, and 11 on Monday. Here's the relatively new information. Everything we're going to see today toward the end of class involves properties of logarithms. The only reason why we struggle with that is because we use logarithms to solve exponential equations. So here we go. There are a number of exponential equations we have here, and there are fundamentally 4 different ways we can solve exponential equations. This example, number 12, illustrates one way to solve exponential equations. If I have an exponential equation, one way to solve is by writing both sides of the equation to the same base. So I've got 3 to the 4x times 3 to the x squared, and I've got this 1/27. I should recognize that 27 is really 3 to the 3rd power. So if I write this whole equation as 3 to the 4x times 3 to the x squared is equal to 3 to the negative 3 power, I've got the same base on both sides. Well, if I'm multiplying these two things, what happens when I multiply exponents? Or multiply numbers. When I multiply numbers, I add the exponents. This is 3 raised to the 4x plus x squared power, which is alleged to be equal to 3 to the negative x. Oh, now we have 3 to a power on one side, the same base to a different power on the other side. That means these two powers must be equal. I can write 4x plus x squared is equal to negative 3. We're back in Math 100. It looks like an old-fashioned quadratic equation. So remember, to solve quadratics, we dump everything on one side. So I have x squared plus 4x plus 3 is equal to 0. I hope that'll factor. Maybe it'll factor into the product of 2 binomials, maybe x times x, and the last sign is positive, the middle sign is positive. The factors of 3 are 3 and 1, x plus 3 times x plus 1 would give me that calculation, but we're not done, because when I'm using the 0 property, I'm multiplying two things and get 0 for an answer. Either one of those could be 0. So either quantity x plus 3 is equal to 0, or quantity x plus 1 equals 0. X could be equal to negative 3, or x could be equal to negative 1. But remember, we're trying to solve that equation. So let's try to verify that by looking at both of the answers that we have here. So how do we verify that? We think maybe negative 3 is an answer. I'll go to my calculator, I'll clear my screen and say, what if I substitute in the first expression? I've got 3 raised to the, it says 4 times x. Well, I'll say 4 times negative 3, because I think negative 3 is an answer. So I'm trying to verify this. And then I multiply this by 3 raised to the x squared power. Well, I think x is a negative 3, and I'm gonna, need to get rid of this. I have an exponent. I think x is negative 3, the quantity negative 3 is being squared. Is everyone good with me in seeing what I'm trying to do? I'm trying to verify that negative 3 is indeed a correct answer to that original exponential equation. Now, when I do this calculation, what should I get? I should get 1/27, and I get this silly looking fraction. But that is 1/27 because my wonderful calculator says in my math menu, I can change anything on the screen to a fraction. That is 1/27. So we verified the first answer. We don't know if the second answer is also correct, or it may be a pseudo root. So I need to verify that negative 1 is a correct answer, which means I go back to the original equation and I plug in a negative 1 for x. How sweet it is for us, we can go back up here and we just have to edit. I think x could be a negative 1. And if I think x could be a negative 1, let's put a 1 there. And I think x could be a negative 1 in here. When I do that calculation, I come up with, again, the same thing. So we have 2 possible answers for that exponential equation. So what's the takeaway? The takeaway is one of the techniques that you have when you're solving exponential equations is create the same base on both sides, do the algebra of exponents on both sides, and as soon as you have that same base equal to different exponents, those different exponents have to be equal, and they'll usually take you to some kind of algebra, math 100 kind of expression to solve. Now, another kind of exponential equation, e to some power gives me 1,000. Sometimes you can use the properties of logarithms to solve exponential equations. So let's take the natural log of both sides. Natural log of e to the third equals the natural log of 1,000. As long as I do the same things to both sides, I'm fine. I remember one of the properties of logarithms is the logarithm of a number to a power. That power becomes the coefficient of the logarithm because powers to powers, you multiply exponents, and logs are exponents. So that's really 3 times the natural log of e is equal to the natural log of 1,000. Well, the natural log of e is 1. Why? Natural log of e is 1 because if I take my base e and raise it to the first power, I get the number e to the first power. So this really tells me the natural log of e is 1, 3 is equal. What am I trying? I'm sorry. I'm solving for y. I misread that.
Oh, so good.
I should get my glasses changed. This is e to the y equals 1,000. E to the third is not. E to the third is not equal to 1,000. So pardon that. I can't read my small typing there. I have e to the y is equal to 1,000. I can take the natural log of both sides when sometimes doing that will solve a log an exponential equation. So I'll pick the log of e to the y equals the natural log of 1,000. Log of something to a power, that power becomes the coefficient of the log. So y times the log of e is the log of 1,000. And the log of e is 1. So y is the natural log of 1,000. So we think that's the answer. Let's check. Go back to my calculator. I want to check that this answer, the natural log of 1,000, makes this expression correct, e to the y. So I say, okay, let's take e. And let's raise it to the y power, and we said here y is the log of 1,000. So natural log of 1,000. And what should I get as my answer? Well, we should see exponential functions undo log functions. We should get 1,000, and we do. So we know that we have solved it correctly. So far, 2 methods of solving exponential equations. Get the same base on both sides, or just take the natural log of both sides. Or the most difficult kind of exponential equation is something like this, where you have different bases on both sides. Your only option there is to take a natural log of both sides. So let's see what happens. Natural log of 5 equals the natural log of 3 raised to the x plus 1 power.
That intro got me
Now, I use all the properties of logarithms to simplify that. I have natural log of 5 to the x power equals natural log of 3 to the x plus 1. On both sides, I've got the log of something to a power. So, powers to powers, we multiply exponents. X times the natural log of 5 equals, on the other side, the quantity x plus 1, that's the whole exponent, times the natural log of 3. So, this is probably the most difficult way to solve an exponential function, but you don't have any other options, simply taking a natural log of both sides. But your game is you need to solve for x. So you need to get all the x's on one side and everything else on the other side. Well, guess what? We have to distribute. On the left side is x times the log of 5. On the right side you've got x plus 1 times log of 3. I have to distribute log of 3 times x log of 3 times x, and log of 3 times 1. Now remember, what's my objective? My objective is to get the x by itself. Well, I have two terms here that have x's. So let's get all the x terms on one side by adding minus log of 3 times x to this side, minus log of 3 times x on that side. So what I have left on the left-hand side is x times the log of 5 minus, we can write it x times the log of 3 equals what's left on the right-hand side, natural log of 3. Looks kind of confusing, but here's the breakthrough. I see x is joined to those two, not those two terms. It's joined by multiplication. Let me factor it out. Factor out the x.